Hi and welcome back. In this video, I wanted to show you a little bit about deleting nodes in a binary tree. Deleting nodes is the most complicated part of dealing with a binary tree because, you can delete any node in here. So let's start talking about deleting nodes and you'll progressively understand why it's such a complicated thing. Let's start with this tree here as an example. And let's imagine we want to delete the node 3. Let's say we want to delete 3 from this tree. The first thing we have to think about is what makes 3 be in this tree? So that's maybe a bit of a strange question, but remember we've got our binary tree object, and the binary tree object knows about this head node, the root of the tree. It doesn't know about any other nodes. Right? The binary tree object only knows about this 6. And the 6 points to 5 and 6 points to 9. That's the left and the right. So you could say that 5 is in the tree because the head points to it. If the head did not point to it, then you wouldn't know that it's in the tree, so therefore it wouldn't be in the tree. Similarly, 3 is in the tree because 5 points to it and the head points to 5. It's the relationships between these nodes that end up describing the tree. If you made 5 not point to 3, if you deleted this arrow, nothing would point to 3. You wouldn't have any variables of this node, and Python would recognize that there are no variables referencing this node, nothing is pointing to it, it's completely isolated, you've got no way of accessing this node in your program. And when Python realizes that, what it does is it deletes it from memory, or at least it allows other programs to overtake that memory and other variables to overwrite that memory. So if nothing points to a node, that is essentially the same as deleting it, because Python takes care of that for you. Now, with that said, if we wanted to delete this node 3, now all you have to do is make node 5 not point to it. If instead of 3, we point to just, if instead of 3, we just point to, say, none, then 3 is deleted. The 3 would still be here somewhere, but Python would be aware that you're not using it, and it would eventually erase it from memory, or it would be overwritten by something else. So that's how you delete a node that has no children itself. Notice how 3 has no left and no right. When a node has no left and no right, all you have to do is set the parent to not point to it anymore. If the parent, let's say you wanted to delete node number 5 here, which does have a child. 5 points to 3. If you now say 6 doesn't point to 5, what you've done is you've deleted 5 and 3. So you've deleted the entire branch here. And that may not be what you want. So if you want to delete node 5 only, knowing that it has only one child, all you have to do is delete 5 and make 6 point to 3. Essentially, skip over 5. The way to do that is just make 6 point to 3 straight away, like this. Nothing points to 5 now. 6 doesn't point to 5. 3 doesn't point to 5, even though 5 points to 3. Nothing points to 3, and if you don't have a variable for this node, it would get erased from memory as well. So when you want to delete a node that has one child, all you have to do is point the parent over to the child, and then nothing points to the initial parent 5. Those two are the sort of easy scenarios in a tree deletion. When you have no children, very easy, just point to none. When you have one child, very easy, just get the parent to point to the child instead of the node. But when you want to delete a node that has 2 children, then it becomes a bit more complicated. Here's why. When you want to delete 5, all you do is make 6 point to the child. if you want to delete 9, maybe you'd think, hey, just make 6 point to the child, right? That'll do it. And it doesn't quite work that way. See, because imagine you decide to make 6 point to 7. Now 6 point to 7, 7 points to 8, but nothing points to all of this. So you delete 9, 12, and 11 in its entirety, because nothing points to 9, so Python removes it. Nothing points to 12 if 9's deleted, so Python removes that, and then nothing points to 11, so Python removes that. So not great. Also, you can't just... it would be nice if you could do this. If you could sort of delete 9 and put 7 in here, but then you'd have to sort of delete this and make 7 point to 8. And this doesn't work, because now 8 is at the left, and 8 cannot be at the left of 7, because that would be strange, right? 8 is bigger than 7, so it should be at the right, but 12 is also bigger than 7, so it should also be at the right, and now 7 ends up with 2 right nodes, which you cannot have. So how do we do this? Well, 9 has 2 children, which we're going to call 2 sub-branches, right? We've got a left branch here, and we've got a right branch here. And we said we can't put 7 here, because then, right, what do we do with the 8? But we can put 8 here, and delete that. This is okay. Now 7 is smaller than 8, and it stays at the left. 12 is bigger than 8, and it stays at the right, so this is fine. Similarly, we can put 11 here, this child, and delete 11 from here. 7 is smaller than 11, so this is fine, and 12 is bigger than 11, so this is fine. Okay, so what am I doing? What I'm doing is, in the left branch, you can pick the node that is most to the right. Okay, so in here, in this branch, the rightmost node is 8. You know that's going to be the biggest node in this branch. The biggest node in the branch is always going to be bigger than this one, right? And because it's in this branch, the biggest node is 8, therefore 8 has to be bigger than 7. And not only that, but you know that the biggest node in this branch is always going to be smaller than this node. Why? Because if this node was bigger than this one, it would end up here. So when you're deleting a node with 2 children, you can just replace the node by the largest node in the left branch, or by the smallest node in the right branch, the leftmost node in the right branch. Those are the 2 options. Either the largest node in the left branch or the smallest node in the right branch. That gives you one node that is closest to this one. And then you can replace it, essentially put 8 here, and delete this one. And what we're doing there is just saying, this is the node we want to delete, so the parent is now going to point to the rightmost node in the left sub-branch. Sorry about that. So the parent is going to point to the rightmost node in the left sub-branch. This node's parent is going to point to none, going to get deleted, and the 8 node is going to point to this and this, the children of the original node you wanted to delete. Programming that is not so simple. Let me tell you that. There is quite a lot of code that we have to write in order to get that deletion working. But I just wanted you to be aware of these difficulties as we start in the next video at coding this deletion. Okay? So thanks for joining me, and I'll see you on the next video.